Alright, time for another math. Easy solution. We're going to discuss some more derivative rules and look at the quotient rule and look at derive a proof for it. It's similar to the product rule what I proved before. So basically the quotient rule is if you have a function, let's say y equals f of x divided by g of x, basically one function divided by another, then the derivative is just going to be equal to, well, y prime, or you could also write it as d over dx of f of x over g of x. Then this derivative is just going to be equal to g of x times derivative of f of x, or f prime of x, minus f of x, so you just rearrange them. So we'll have g prime of x, all divided by g of x. This is going to be all squared. So that's a quotient rule. And to derive this, we'll look at, we'll have to, well, first I'll let basically u equals f of x. I'll use it in derivation to make it easier. And v is equal to g of x. Okay, so now if we have, let's say this is, so y of x would equal to, well, we'll just write u over v. And then if we were to increment, let's say increment by delta x, so then we'll have y of x plus delta x. This is going to be equal to u of x plus delta x over v of x plus delta x. So basically u of x plus delta x, and the other one is this is going to be original u, and then it's going to be plus, let's say, a change in u, and the other one, which is v of x plus delta x. All it is going to be, you're just changing the value, so it's going to be, again, it's going to be v plus delta v. So if we write this out, so now basically we have this. So if we want to get the, let's say, the change in y, it's going to be change in u over v. This is going to be equal to this. Yeah, this delta sign means change. That's the delta is a Greek symbol. Basically, so this is going to be equal to, we're going to have it u plus delta u. This is the new u. This is x plus delta x. So u plus delta u divided by v plus delta v. Then subtract by original value, which was u over v. And then if we just basically add these up, so we need a common denominator, so we'll just times this by v plus delta v, which is the same as this, and divided by v plus delta v. Just so we can have the same denominator, we'll times this by v and divide by v, this whole thing. And then we can add these now, and then we can also rearrange this or multiply this inside, so expand it. So we'll have u times v minus u times v, then subtracted by u times delta v, and all this divided by, then all divided by v plus delta v over v. Then this one right here, if you look at this, cancels, are the same, and so then we're left with a delta y is equal to delta u over v. This equals to delta u times v minus u times delta v, all divided by v plus delta v times v. So now if we want the let's say the average slope, we'll basically divide this by delta x. We'll have, so this is basically the slope, or the average slope. This is going to be u over v over x. And then if you divide this out by here, this is going to be, so you divide by through each one of these, because that's just how you do division here. So then you'll have v times delta u over delta x minus u times delta v over delta x, all over v plus delta v times v. Because basically if you have something, let's say 1 over delta x here, or v, you could divide these out separately. So it's going to be equal the same thing. So that's all we did here, delta x. So we just times everything by 1 over delta x. So now what we have here, if we were to take, let's say, the limit as delta x goes to 0 of y of x, then this is basically the limit. This is, if you see my other video on Lebanese notation or just derivative notations, this is basically the limit. This is going to be equal to d, yes, dy over dx, or just y prime and whatnot. So then this is basically, that's our y prime. And then this can be equal to limit You could do the limit of every single one here. We'll take the v out. We'll do on the top part. This one is a function of x, but we're doing but so then the delta x doesn't affect it. So then this is gonna be u over delta x minus u. Take that out. Limit x delta 0, and this one's v over delta x, all divided by limit of, we'll take the v out again, of v plus delta v of delta x goes to 0. So basically now this one here, if you just look at this one, this is basically u prime, and then this one right here, this is v prime. So now, and then over this side, if you want to solve this limit, basically the v doesn't get affected by delta x, so it's going to be v plus the limit at the delta v. So basically, as delta x goes to 0, so let's write as, then basically delta v goes to 0 as well, because if you're not changing v, then the delta v just means you're not changing it, so it's 0. So then this one, so if you if you write them all together again, we're going to have y primes equal to v times u prime minus u times v prime, all divided by, well, v squared. V, you're left with v here. Okay, and then this one, if you were to put it all, put f of x and g of x back, you'll have g of x times f prime of x minus f of x times g prime of x, all divided by g of x, which is v squared. So basically there's our quotient rule. Quotient rule. So there's our derivation of it. I'll show you another video that we could use basically the chain rule and the product rule. I'll prove what chain rule is later. We'll use it a lot in calculus. And I'll show you could derive this easier with that and the product rule. And also, yeah, you would just to solve equations with that is better. So now if you look at an example, let's say ex equals, example, y is equal to e to the x divided by 1 plus x squared. So if we want to take the derivative of this, well, this is a function divided by another function. We'll just use quotient rule. So if we want to get derivative of it, so we'll just here we could quickly think of we'll just let u is equal to e to the x. So we'll just say let, so we just define it, and then v is equal to 1 plus x squared. So we know that here v prime, this one's just going to be 2x because this one's 0, this is 2 using power rule, and then the derivative of u is basically u prime is equal to, well, e to the x. That's what special about e. So now if we do this, y prime is then going to be equal to, well, it's going to be equal to this v, which in this case is 1 plus x squared. So 1 plus x squared times it by u prime, which is e to the x, minus v prime, which is 2x, times basically u, so e to the x. So now I'll divide this out by v, which is x squared, and then we just square it. So if we simplify this, we'll get e to the x of basically x squared, well, just 2x plus 1. So we just rearrange that. All divided by 1x squared over squared. So basically this is so that's our answer. We could stop here, or we could further simplify this x squared minus 2x plus 1. Yeah, so if we were to complete the square in this case here, we'll get basically x minus 1 squared, because basically so this number here times it by itself is plus 1, and then add it together is negative 2. That's a quick way to factor or complete the square. You see my other video on that. So this basically, if you want to quickly see the proof, this is going to be, if you expand this out, this is going to be basically x squared minus 2x plus 1. Yeah, so then the final answer, you could simplify it, is basically y prime is equal to e to the x of x minus 1 squared, all divided by 1 plus x squared, all squared. So basically that's quick application here. I'll show you another video where you won't need to memorize this. You could just use the product rule and chain rule, because you could just use product rule here and you could just have it as, let's say, e to the x 1 or 1 plus x squared, and then you could just use a chain rule. You use a chain rule and the product rule of this. So you have this times this, and you could do that way. But yeah, so well, yeah, thanks for watching. Hopefully you learned and learn about quotient rule. Stay tuned for another math easy solution.